In this video, we're just going to have a quick look at the Mars simulator for MIPS, have a look at a quick example about how this relates to the high-level languages that we're used to, see some of the registers in action, and see how to print things and pass in values to your code. Okay, so when you start on Mars, this is the page you should be confronted with. You won't have any code up here, I've written this in, but you should have your editor over here where you can write your own code. You have a little terminal down here for returning values, printing values, that sort of thing. And you have a bunch of registers over here, which should mostly be 0 until we start using it. Okay, so other things to see in here. This is the assemble button. This allows you to, what you could think of as compiling your code in BlueJ for Java. This does the same thing, but assembles the code down to machine code, as you saw from lecture 1. The assembled language goes to machine code and is then executed. This is the run button. You can also run it step by step using this button. You don't need to, but sometimes it's useful to see, stepping through your program bit by bit, how it works. There's also a handy function over here called help, which we'll have a look at in just a second. But a file that's going to be vital to you is this, your MIPS summary sheet. And this has almost all of the instructions you will need to know in this class. You will always have this. I will never ask you to memorize these functions. I don't really see any point in you memorizing them. It's more the understanding behind how you employ them and use them that's important here. So I'll always give you this. You don't need to worry about that, whether it's a class test, an exam, whatever it is, you'll be given access to this. So you can see that you've got a bunch of instructions here. You've got arithmetic up here, you've got some logic commands, some loading and storing. These are quite important. It's important to use the right one in the right context. You have a bunch over here, but these ones we'll get onto later on in the class. Also down here, you have something that's quite useful, is some register descriptions. So ones that we'll be using today is v0. You can see that there's a return value here. You have a constant 0 register, that might be handy for you at times. You have arguments, some temporary files are temporary registers, and then a bunch of others. But we'll just be using a few today. Also, you don't need to understand everything today. This is just to give you a brief overview of how Mars works, how you can use it, and how you could write some code. So let's go back to Mars and see what's happening there. So I've written up here a little bit of Java pseudocode, or Java code actually I suppose, just to add two numbers together and then print it or return it. So what we want to do today is figure out how we do this using MIPS. So first we need to figure out how we pass in these values num1 to here, because it's not quite as simple as it would be using Java. We've actually got a lot of steps rather than just a couple that we've got up here. So let's start off by importing num1 and num2. So there's two important parts to our MIPS code. There's the .data section. This is where we would do something like this. .data, if you remember your von Neumann diagram where you have the CPU, you have input and output, and then you have memory. This is what's coming in from memory, the .data section. This is where memory gives us something to work with. You could also write out to memory, but we don't need to worry about that just yet. Today we're just going to be focusing on passing in values. So how do we do that? Well, we need to give it a name. So let's say num1. And the convention is you put a colon after that to tell the MIPS that it is a variable name. And then we need to tell it its type. Now if you remember from lecture 1, all the values stored in the registers you always have a 32-bit word. We could use a byte, but a byte's not really going to let us store many numbers. So we're going to be using a word today to represent an integer. So we say .word like that. And then we need to give it an actual value. We can't just give it a variable value yet. We need to give it a hard-coded value. So today I'm just going to give num1 the value of 5. And then I'll do num2 as well. It's going to be the same as num1, but we'll give it a different value. So we'll say 10 there. So the .data section is used for passing in values like this, and this is the format you would use. There's more than just .word. We'll get onto some of them later on, but for today, this is just passing in two integers as far as we're concerned into MIPS. Now also you might notice I said in lecture 1 that all registers store words as hexadecimal values, and that is true. You can look over here and see you've got this strange format of OX, and then you've got 8 hexadecimal values here. They're all set to 0 currently, but you can see down here this one's got a bunch of hex numbers. Mars and MIPS are quite nice in the way that they let us convert between the two so I can pass in 5 and 10 here without having to spell out their 32-bit word format. Okay, so let's move on to the next bit. So now that I've got them and I've passed in values from memory, the next section that we need to look at is .text. Now .text is the actual code part of a MIPS program. This is where we write the code that's actually going to execute at runtime. So now we need to figure out how we get these values, num1 and num2, into MIPS, because this is in memory here, but you can see nothing in our register corresponds to this. So we need to figure out how to load these two words into the program or into some of our registers. So if we go back to our document, our MIPS summary document here, and go down to the load section, I'll make this a wee bit bigger. You can see we've got a bunch of different loading instructions, and it's important to use the right one in the right time. You can see load word here, and you would think that would be useful for us. We are loading two words in from memory, so this is what we want. You can also see here we've got the operands that it takes, and then over here it says what happens, and what this is saying is register R becomes the value of A. So we want to load into register R the value A. So let's see how we would do that in practice. I'm just going to pick a register. I'm going to pick T0 as a temporary register, just for storing temporary values. And I'm going to store in there num1. Now I could equivalently have picked some of the other registers, but these are just temporary value storage registers, the T's, so I'm going to use them for this. And then I'll put in T1 because I don't want to overwrite what's in T2 or T0, num2. Now that should load these values in. But if you look at this code, we've actually got a few more lines than just that. So we need to make x. That needs to happen. We need to figure out how to make an x which is equal to the sum of num1 and num2. So let's figure out how to do that. If we go back here and look at arithmetic, we've got add, and it says the register R is equal to the value of s plus t. So let's use that. So I'm going to say add, and we need to do a little bit of thinking about where we're going to store this. So I'm just going to say T0 and T1. These are the two values we're adding together. And then we need to figure out where to put this value. Now, if we go back here to the document viewer, these it says here these are the return value registers. Now, you might think that that means we need to put it in V0 because it's a return value, so we just put it in V0 and then we print from there. But actually, it's a little bit more complicated than that. V0 is the equivalent to this up here, where we tell the function the type of what we're returning. So in Java, if you put an integer up here, then you have to return an integer. Otherwise, it's not going to work. So similarly, we need to tell MIPS what kind of value we're going to be printing out, and that's what we use V0 for. In fact, if you go into this little help button up here, you've also got a bunch of instructions in here, which you don't need to know all of them, but we've got what are called syscalls. Now, syscalls tell us what we need to put in V0 to print out certain different values. So print integer is 1, and if you look at the arguments, it says A0 is equal to integer to print. And that's why I didn't put a value in add, because we need to figure out where to put it. So what this says is put the value of 1 into V0, and then I will print out the integer for you that's stored in A0. And so we need to put A0 in here. So now we're adding T0 to T1 and we're storing that in A0, but that instruction also told us that we need to store the value of 1 in V0 for it to happen. So if I go back to my document viewer and have a look at more loading and storing, because I need to load the value of 1 into register V0, this might not make sense, but this instruction here, the load immediate, is what you need to use for that. This allows us to load an immediate value that hasn't been passed in from memory like num1 and num2 were, straight into a register. So I'm going to do load immediate, I'm going to load into V0, and I'm going to put the value of 1. And that's like putting this in up here. And this adding into A0 is kind of like this whole section here, where we do the returning and the adding. Now we're not quite done, even though you might think we are. If we want this to actually execute what's in V0, we need to do a syscall. And this says, oh no, you actually do need to print out that value. Nope, if I could type. There we go. So now we have our code that corresponds to this Java, and you can see that it's a lot more complex than it would be in Java, because we're having to deal with the actual nitty-gritty of working with registers and loading values to and from them, storing values, and then printing out by hand, as it were. As where Java abstracts a lot of this away, we need to do the nitty-gritty here. Okay, so and then let's assemble our code. And so if you remember from the first lecture, I said that the control unit gets a bunch of instructions. It has a program counter that tells us where the next instruction is, and it takes the machine code value there, decodes it, and executes it. And that's what's happening here. We have the registers here, the addresses where our commands are stored. So this is our program, and this is where the instructions are being broken down to. And if we look over here, we've got a little program counter register, and that's pointed to the same place that our first instruction is stored. So the code is going to go through all of these registers, carrying out the instructions as it goes. And now, if we run our code, we should hopefully print out the value of 15. And there we go, we printed it out. There's 2 there just because I've done this a couple of times, but this is the value that we printed out. Now, if we look over to our registers, you can see that A0 has the value of F, which is 15, stored in it. That's the result of our calculation. And we can see that T0 has 5 stored in it, and that T1 has A stored in it. And we can see that the program counter has gotten to this address down here, which just passed our last instruction. So that's everything that we're going to go through today. I just wanted to give you a brief idea of how we might write some code using the Mars simulator and MIPS, and how it ties into what we would take for granted in Java. I don't expect you to understand absolutely everything here. This is just to give you a rough idea of how you use this program, how you write code for MIPS, that sort of thing. If you have any questions about anything I've covered here, please do let me know. Thanks.